All right, good afternoon, everyone. Thanks for joining us on this beautiful Friday in Merced. It's my pleasure to introduce Harald Wiltsche, who is a professor at Linköping in the university. I hope I got it right. It took me a while, but luckily it's on the slides, which is in Sweden. He did his undergrad and graduate work, if those categories apply, in Graz, in Austria, where he's from, and then a postdoc, I think, in Toronto, and back to Graz.
Yes.
And now at Linköping, but has done, was been visiting at Princeton and at Stanford a few times now. And we met actually via social media, so it's not all bad. You get to meet people. And
still Twitter, right?
I think back when Twitter was Twitter, we have very similar, I'd say. In fact, the work of Harald and his student Philip Berghofer. It's very rare that this happens where I read something and like the clouds part and I'm like, yeah, this was what was missing in Husserl scholarship, because Husserl's, I'm sorry, this is not my lecture, this is your lecture, I'm almost done. But Husserl could be very painful to read, and it sounds like he's saying these extremely strong claims, and their work has really made it much more plausible, brought out this kind of fallibilist strain in Husserl, and just made it much more accessible and said all the right things, and kind of there's a lot of sociology of phenomenology of these different groups that go in different directions, and it's this very straightforward, let's figure it out, let's apply it to cases, and in Harald's case, looking at a lot of science and physics and how phenomenology intersects with that. So please join me in welcoming Professor Wiltsche to Dogmas of Phenomenology.
Well, thank you so much. First of all, thanks so much for all of you for being here today, and then second of all, of course, thank you so much for the kind invitation. I'm super excited to be here today to share some of my ideas with you. Thanks so much for the invitation. It's a pleasure and a privilege. Two Dogmas of Phenomenology is the title of my talk, and maybe a good place to start is to maybe give you two basic intuitions you might have about science, right? And one of these intuitions might be if you basically, if you go out and talk to someone on the street, what's science supposed to do? What's the aim of science? What are we expecting to get from science? Then I guess many people would tell you a story a little bit like this. They would say, yeah, science is the business of basically telling us what the world is like. This is what science wants to do. And if things get a little bit more sophisticated, they will say things like, science at the end of the day aims at something like a description of objective reality. And then you're off to the races and you could ask, okay, great, what's objectivity then supposed to mean here? And then maybe the person, and this is a kind of a understanding of objectivity you might often get in popular science presentation, but also sometimes really in textbooks, people would say, yeah, a description is objective if and only if it kind of subtracts from the observer. It takes the observer out of the description of reality you're getting. So you take out the subject, the perspective, everything that's contingent, and what remains, that's your objective description. So sometimes people talk about this in terms of what science is aiming for is this proverbial view from nowhere. So the scientists, like all the observers and all the perspectives, kind of disappear from the image science is supposed to give you. So this is one intuition. But then there is a second intuition that kind of pulls in a different direction. And that would be the intuition that kind of stands a little bit in the way of this objectivist interpretation of science. And the intuition here would be to say, yeah, but hold on a moment. I mean, theories and models, so the kinds of things through which science speaks, I mean, they're not falling from the sky, right? I mean, they're constructed, interpreted, they're revised, and humans do that. And the same is true with the more experimental side of things. I mean, experiments, if you talk to people actually doing experiments, you will notice experiments as well. They depend on judgment, interpretation. There is a lot of skill, and many of these things are actually quite hard to express in the form of propositional knowledge. And also, speaking of knowledge, I mean, the end product of science obviously is something that is produced within very concrete, embodied, and historically and socially situated practices. And in a way, you can think that these two intuitions really kind of produce a kind of a puzzle. And in a way, it's a puzzle if you look, for instance, at some of the discussions that happened, especially in the 80s and 90s, between philosophers of science on the one hand and sociologists of science. It was really at the heart, the clash of these two intuitions, because the puzzle you seem to be left with is, how can a practice that's historically and socially situated generate claims and generate a product that is supposed to transcend any of these particular situations, right? This, at the heart of, if you're interested in science, could be a puzzle you might be worrying about. I will talk about phenomenology today, and in some respects you could think that, well, if you're presenting the problem in the form of this puzzle, then actually phenomenology seems to be the perfect matchmaker. Because if you read phenomenology really since its very inception, it seems like phenomenology is literally built around acknowledging this puzzle and also around the attempt to solve this puzzle. And I will not argue for this in a lot of detail. Let me just give you one passage from one really of the founding documents of phenomenology. This is Husserl's Logical Investigations. This is how phenomenology entered the stage of European intellectual culture in 1900, 1901. So here's the passage. How are we to understand the fact that the intrinsic being of objectivity becomes presented, apprehended, knowledge, and so ends up by becoming subjective? What does it mean to say that the object has intrinsic being and is given a knowledge? How can the ideality of the universal or concept or law enter the flux of real mental states and become an epistemic possession of the thinking person? So in a way, what you see here are two things. First of all, what an awful writer Husserl was, also that's one point of having this passage. But then second of all, it seems like to be a direct response to the very puzzle I started with. And if this is true, then you should actually expect that there are bookshelves after bookshelves after bookshelves filled with phenomenological analysis of all kinds of different scientific practices, because my description of the basic puzzle is correct, and if it's correct that phenomenology seems to address this very puzzle, there should be a lot of work on phenomenology of science. Let me share with you a live feed of these many bookshelves, because they look a little bit like this. The reality is that phenomenology of science, for the most part, it changed a little bit over the last couple of years, but it's really not a thing. If you look at the work phenomenologists are doing, they're interested in all kinds of things, and these are very interesting studies, don't get me wrong. But I mean, the topics typically at the moment, I feel like, is a little bit more emotions is a topic phenomenologists work a lot on, empathy, religious experience, art, all kinds of things, but science, usually not. And this basically is the starting point for my talk today, because the question really is, why? Why is there no phenomenology of science? And I mean, speaking of sociological considerations and historical analysis, and I'm interested in that kind of stuff, one option now for my talk would be to actually talk about history and sociology, and then I would end up talking about migration histories of intellectuals from Europe during the Nazi regime to North America, and how different groups of intellectuals ended up at different institutions, and how for sometimes very contingent reasons people ended up in two different camps, which in professional philosophy we unfortunately refer to as analytic versus continental. I think a very unfruitful way to slice up the cake, but it's still a reality. But I'm not going to talk about history and sociology today. What I want to focus on is the more philosophical part of the story, the systematic part of the story. And I want to focus on one argument in particular, which I think is at the heart of a lot of thinking, not only of Husserl. You find similar arguments, by the way, in neo-Kantian authors. In a way, it all really goes back to original Kantian arguments, but I will focus on Husserl today. There is one argument that does a lot of work over the decades to keep phenomenology and the sciences apart. And the argument goes a little bit like this, and I will analyze this in much more detail. Phenomenology is a transcendental project, and I will explain in a little bit more detail what that actually means. But since it is a transcendental project, phenomenology operates on a categorically distinct level than from the positive sciences. What phenomenology does is to analyze the necessary conditions of the possibility of science, but not science itself. And that kind of seems to put phenomenology and the positive sciences really on two completely different levels and makes it actually quite hard for them to communicate. And my claim is going to be that this is simply not true. There are no good arguments for this. And what I will be saying is that phenomenology can and should fruitfully interact with the sciences, but what might be a little bit different from similar talks you might have heard, I don't consider myself to be part of the naturalizing phenomenology project, because sometimes how this union between the sciences and phenomenology plays out is basically to say phenomenology needs to open up to the methods of the sciences. Phenomenology should be fully naturalized itself. To some extent, I'm going in the exact opposite direction. I think science needs to become transcendental, and that's the punchline at the end. Let me quickly say something about the structure of the talk. You might wonder, why two dogmas of phenomenology? Well, first of all, because there was a paper I wanted to kind of allude to. And second of all, in the paper, I'm actually talking about two dogmas. Today, to keep things short and compact, I will only focus on one, namely what Husserl calls the naivety of the sciences. I will explain what this is. The second dogma, for those who are interested, is the claim that the structures of consciousness cannot be mathematized, which I think is also not true, but I will not talk about this today. So the first part, I will describe the dogma, naivety of the sciences. Then I will go through two possible counter-arguments, which I think at the end of the day are not convincing, and I will present quasi-Husserlian responses to these arguments. That's part two of the talk, which concerns two responses. But then I want to focus on what I think is the actual topic we should be discussing, namely what I call the representational nature of theories or of science more generally, because I think that claim that theories and models always necessarily need to be representational vehicles of some physical system, that's at the core of the whole discussion. And then I will talk about QBism, an interpretation of quantum mechanics, simply because that is a version of science where the theory we're talking about, namely quantum mechanics, is not representational. And what this means for the overall argument is what I will discuss in the final part, in the conclusion when I wrap things up. All right, so if you read Husserl, it doesn't take long for you to stumble across passages which A, you don't understand, and B, where Husserl talks about the necessary naivety of all sciences. This is something Husserl says all the time. And basically what he's claiming is that there is a necessary naivety that characterizes not only the natural attitude, so he talks about the naivety of our everyday life, just the way how we interact with life-world objects around us, but also, according to Husserl, the positive sciences, even mathematics and logic are characterized by a fundamental and necessary naivety. I mean, first of all, this is a very, I think, unnecessarily provocative thing to say. Like, if I'm a scientist and the philosopher tells me that everything I'm doing is naive, then I think, yeah. This is the thing, if you're giving a talk which is not in your native language, like the sentence in my head is, I would be pissed. Now I know I should talk in a more polite way, but I'm not finding the right words, but so you know how I would react if I was a scientist. And if I was an English native scientist, I would find polite words for what I feel. But I think it's important in all defense of Husserl to also realize that naivety in the Husserlian system is a technical term. So let's first look at what Husserl actually thinks naivety is supposed to mean. And again, I will torture you with a a little bit longer passage from Philosophy as Rigorous Science, because I think this is one of the clearer descriptions of what Husserl thinks naivety is actually supposed to mean. So here it goes. All natural science is naive in regard to its point of departure. The nature that it will investigate is for it simply there. Natural science accepts nature as a given, and this is a naivety that in natural science is, so to speak, immortal. It is true, of course, that natural science is, in its own way, very real. Isolated experience, even when it's accumulated, is still worth little to it. Still, no matter how satisfactory this kind of inner scientific critique of experience may be, as long as we remain within natural science and think according to its point of view, a completely different critique of experience is still possible and indispensable. A critique that places in question all experience as such and the sort of thinking proper to empirical science. Okay, let's unpack what Husserl is actually saying here. So the first thing is that, Husserl was a mathematician who turned into a philosopher. So he had a PhD in mathematics. And also the topic of his dissertation is actually quite interesting because he wrote on the calculus of variations, which is an area of mathematics which is very close. This is not pure math. This is very close to actual physical practice. In the theory of calculation, in the calculus of variations, you figure, for instance, out what a geodesic is, the shortest connection between 2 points. That's basically how we describe gravitation and general relativity. So he was, from his mathematical side, very much familiar with the kind of style of thinking of physicists. So the first thing we learn from this passage is that what Husserl refers to as this naivety really has nothing at all to do with internal standards of the sciences. I mean, internally, in the way how science deals with data, how it deals with observation, how it deals with experiments, it is, of course, a model of criticality and rigor. This is not what Husserl is talking about. This is not what Husserl would ever deny. What makes the sciences naive is something else, namely what Husserl refers to as their unquestioned presuppositions. And he specifically talks about the point of departure. What does he mean here? Well, basically, according to Husserl, the sciences assume implicitly that there is a nature, that there is some kind of reality out there that, first of all, exists independently of theorizing, independently of the person who does the theorizing or the experimenting. It's not the important point. And that B, this nature can be described through science itself. And if you kind of follow through with this, you end up with an argument that goes a little bit like this. So science presupposes a pre-given nature, very much in the sense that I just spelled out. This presupposition must already be operative before science begins. I mean, if you enter a laboratory and you don't share this basic presupposition, then this really undermines the very practice you're about to engage with, right? This is Husserl's point. And then, therefore, science cannot examine this presupposition, and this is the important part about circularity. So basically, the argument is the presupposition must already be in place in order for science to begin. But if that is correct, you cannot use the findings of science in order to analyze and study this very presupposition, because you end up in a basic circularity. And this, according to Husserl, is why we need a completely different type of inquiry. In Husserl's mind, that is phenomenology. And what's important about it is that the analysis of phenomenology itself cannot be grounded in positive scientific findings, because their task is to clarify the conditions that make such findings possible. And this is really important to realize that this is, I don't know, logical is probably not the right word, but it's a structural point. It's the basic point which you find a lot of transcendental philosophizing about. Not only the sciences, also this is a very typical counter-argument against naturalized epistemology from transcendental philosophers. Basically, just as the axioms of Euclidean geometry cannot be proven within Euclidean geometry itself, the transcendental conditions cannot be analyzed within the framework for which they are constitutive. If you do so, you're basically engaging in a kind of circularity that is vicious and undermines your analysis. let me now start with the two concerns against this basic view. This is, I think, the core of the argument through which Husserl basically wants to show that the sciences are necessarily naive and that there is a strict separation between what phenomenology does and between what the positive sciences are doing. And the first concern you could have is to say, look, Harald, yeah, sure, the circularity thing. I mean, first of all, we need to discuss, is it really problematic to have a circularity of this sort? But maybe another question you could ask yourself is, I mean, that's a very typical philosophical argument. It's, you know, three-step thing. Yeah, sure, I can kind of see the point. But really, can an argument that's as simple and as straightforward as that really affect science as a whole in all its manifestations, in all historical manifestations, in all areas? Is this really something that's so fundamental that it's true of all of it? And you could refer to an example to actually make your point a little bit more vivid. You could say, look, if you look in the history of physics, for instance, I mean, absolute time and space were metaphysical presuppositions of classical Newtonian mechanics. So the idea that space is a container, and every physical occurrence you can study is basically located in that big container. Regarding to time, the thinking was basically time just flows. Everyone who's using whatever kind of time measuring apparatus is measuring the same thing, because time is just objectively out there. So in that sense, the assumption of absolute time and space were very much in the sense Husserl was talking about, the point of departure of classical Newtonian physics, in the sense that this is really something that precedes, for instance, concrete measuring practices. But as we also know from the history of physics, already in the 19th century, people like Lorentz, Poincaré basically realized that the very measurements of time and space depend on the relative motions of the observers. And that's weird, because how can space and time be absolute, but the measurements are relative to something else? How does that work? And this was basically the kind of middle step where Einstein took things further into a next level by basically arguing that time and space themselves are relative. And this is basically just to say that you give up the metaphysics behind the Newtonian worldview. And in a way you could say, if you look at this example, I mean, doesn't this show that science is perfectly able, without the help of philosophers, let alone phenomenologists, to scrutinize its own point of departure? I mean, in this example, what happens is that absolute time and space is replaced by four-dimensional space-time. I mean, which more radical change could you want? Isn't that a quite radical overthrowing of science's own presuppositions? Sure is. I mean, my point definitely is not to underemphasize the revolutionary impact of relativity theory, but what Husserl does not want to say with his whole talk about the naivety of the sciences, he's not denying that science sometimes replaces one very fundamental metaphysical presupposition with another. And more generally, when Husserl talks about the naivety of the sciences, I mean, this naivety does not lie in adopting presupposition A or presupposition B or presupposition C or any presuppositions of that kind. Rather, what Husserl means when he talks about the naivety of the sciences is really a result of a general undemanding attitude. Science simply takes for granted that something exists out there that can be investigated. And this very assumption remains in place even when particular theories, when particular paradigms, or when even very fundamental metaphysical assumptions change. So basically, from a Husserlian perspective, classical mechanics and relativity theory are indeed equally naive. Why? Well, because both presuppose that something exists to be investigated. And even if you rely on very fundamental metaphysical assumptions and you say this assumption is better than that one, this still presupposes that you suppose there is something out there in relation to which one of these two presuppositions can be more adequate. But this also means, and we will come back to this, that if you want to get out of this naivety, what's required is really a radical suspension of all natural position taking, of what Eugen Fink, one of the pupils of Husserl, calls our usual captivation in acceptedness, a basic attitude of simply taking for granted that there is a structure out there which you can investigate. And this radical suspension of all natural position taking is what Husserl aims to achieve through what Husserl calls the phenomenological epochean reduction. And I wasn't quite sure if you're familiar with a little bit of phenomenology, but I will talk about what epochean reduction are in a little bit more detail in a second. So, to quickly summarize where we're at. Sure, scientific theories presuppose metaphysical assumptions. Without them, you don't get science off the ground. And yes, science can internally revise or abandon such assumptions and does that on a regular basis without the help of philosophy. But the point Husserl makes is that even these revisions presuppose something deeper, that there is something out there that can be investigated. And it is this more fundamental assumption that, according to Husserl, is the reason for what he refers to as the naivety of the sciences. All right, let's look at the second concern. I mean, you could say, yeah, okay, whatever. Let's, for the sake of the argument, accept what you just said. But aren't there other cases in history of science where actually scientists themselves, again without the help of philosophers, actually suspended established ontological commitments in much more radical ways, in ways that are actually really similar to what Husserl seems to have in mind when he talks about epochean reduction. And again, an example might help. We are celebrating, depending a little bit on how you count, 100 years of quantum mechanics, and usually what people are talking about is the birth of the new theory of quantum mechanics, the theory that really kind of gets rid of the basic classical ontological assumptions. That happened in 1925 or 26, depending on what you think the founding document of new theory of quantum mechanics is. But at the time when this happened, the old theory, the one you might be familiar with when you have heard about, for instance, the Bohr model of the atom, where basically things look very much still like in classical physics. In 1925, this old quantum theory was facing a lot of fundamental empirical problems, under which eventually it also collapsed. I mean, there were things like photoelectric effect, Zeeman effect. The theory couldn't really account for different molecular spectra, and so on and so on. And if you look at the history of physics, what the reaction of the physicists were, of the founding generations, of the people who came up with quantum mechanics, one response that was especially prevalent in Germany at the time, also in Denmark to some extent due to Bohr, was a radical ontological reset, something that philosophers of physics like Michel Bebot describe as a thorough ontological tabula rasa. And one example of such a radical stepping back from all kinds of ontological assumptions was actually Werner Heisenberg's reduction to observables. What is that? So Heisenberg sought to achieve, and I'm quoting him here, to establish a basis for theoretical quantum mechanics founded exclusively upon relationships between quantities which in principle are observable. And some commentators, some philosophers and historians of physics actually claim that this in fact brings Heisenberg quite close to what phenomenology wanted to achieve. And here's a passage from Michel Bebot where he makes exactly that claim. The two-step structure of Heisenberg's reasoning irresistibly evokes the dynamics of phenomenological reduction. Heisenberg started with sustaining his belief in formal pictures or formal ontologies. And he then redirected attention towards the epistemic acts of measurement and symbolization. These two steps closely correspond to the success of, first, a phenomenological epoche, and second, a reflective move towards the reduced domain. So if you compare this with the earlier case of replacing absolute space and time with four-dimensional space-time, then Heisenberg's reduction to observables indeed appears to be much more radical. Because what you're doing is not to replace one metaphysical assumption with a different one. What you're doing is you're abstaining completely from ontological commitments altogether. And as a matter of fact, I think we can agree, at least at first sight, this move does look strikingly close to Husserl's epoche and phenomenological reduction. But in order to assess this claim in more detail, I think we should talk a little bit about what epoche and reduction actually involve, especially for those of you who are not familiar with phenomenology. This is what I want to do now. So, generally speaking, the epoche is a methodological operation Husserl introduces in order to achieve a stepping back from a straightforward interest in things to a reflective analysis of how things are given or appear to us in experience. And what Husserl, especially towards the end of his career, especially in Crisis, basically emphasizes is that this suspension is not something that occurs just in one blow, in one single step. Rather, reduction in the Husserlian sense of the term unfolds really through several successive epoches and steps, each suspending a further layer of accepted validity. Husserl mentions in the Crisis, for instance, a life-old epoche, but what's more interesting and more relevant in our context is, and Husserl talks explicitly about this in these words, an epoche of objective science. So what is that? What? Let me give you a concrete example to see what I think Husserl is talking about. Consider a cloud chamber. I don't know how many of you are familiar with what a cloud chamber is. Basically, it's a quite crude particle accelerator, crude in the sense of that technologically it's a little bit lo-fi if you compare it to, I don't know, what we're doing at LHC and CERN, but it's a particle detector. It's basically a box filled with supersaturated vapor, and then you shoot subatomic particles through it, and then you see distinctive trails on the display of the thing, and depending on how the trajectory of the trail is, you can kind of see which kind of subatomic particle you are observing. And when you ask an experimentalist who day in, day out, every day, each day, we're in science, so 7 days a week, work with these things, when you ask such an experimentalist what they're actually seeing when they're looking at the screen of the cloud chamber, then probably the answer will be, well, look for yourself. It's a decaying chaos, obviously, right? So in a way, to make sense of this practice, it seems that the cloud chamber really functions a little bit like an extension to the physicist's body. So something that allows you to see things that would be too small or maybe too weird to see otherwise. And in this situation, I think one can quite nicely show what it means to perform this epoche from objective science. Because performing this epoche basically means to step back from exactly this way how a physicist looks and arguably talks about the cloud chamber. What we're suspending is just the habitualized looking and the interpretation that's kind of baked into this looking. And what we're talking about here is this habitual seeing of something as something else. Because once this kind of habitual way of seeing is bracketed, the following becomes much more clearer, namely that what's actually given an experience, what you actually see on the screen of a cloud chamber, are silver gray lines, silver gray condensation lines, and actually, if you're really precise with the description of what's sensuously given to you, it's not even lines. If you zoom in, you actually realize it's just individual droplets, right? And then basically, the line you see, if you just look at it crudely, is something you fill out between the individual droplets. So what's actually given an experience here are these droplets, not chaos. Note that this is really important. I mean, the point of this operation is not to doubt or to actively deny that chaos exists or not. This is not the point of the epoche, so this is not a version of position taking either in favor or against the existence of chaos. All that happened is stepping back allowed you to take a more reflective attitude that makes otherwise implicit assumptions clearly recognizable. I like to think of the epochean reduction in terms of a contrast agent. It's something you inject in order to make structures visible that are there all along. And then the question, which position you are taking to these structures, is a different discussion. So within this reflective attitude, and that's the purpose of performing this operation, we can now compare cloud chamber traces with other representational traces, because of course we know what representational traces are. I mean, one example, and this whole example is actually stolen from Bas van Fraasen, because it's interesting. You could think now about the differences and the similarities between a cloud chamber trail and a vapor trail in the sky, because the physical process actually is a very similar one. In both cases, we're dealing with an ionization effect. And then you can go into a broader philosophical discussion about scientific instruments. And you could ask, okay, should we think of scientific instruments as telescopes into the netherworld? So does the cloud chamber open up a world into things you could not see otherwise? Or is this actually a wrong interpretation of instruments, and we should rather think of these machines really as machines that produce new observables for our theories to be empirically adequate about? Okay? But if this is the epoche of objective science, then note that there is really built into this operation a kind of a limitation. Because if you think what just happened, you will realize that only a very specific class of objects has been bracketed by this operation, by the epoche of the objective sciences. Because what is suspended are really only ontological claims about the quantum objects. What this epoche left completely untouched are commitments, for instance, to meso and macroscopic objects. Like this epoche did not affect at all the cloud chamber itself as a physical object, the laboratory you're in, the university campus you're on, the city you're in, the continent you're living on, and so on and so on. All of these things were not affected by this limited epoche of the objective sciences. And this is precisely also what happens in Heisenberg's reduction to observables. Questions about the being of quantum objects are suspended. That definitely happened. But the macroscopic measurement set remains completely unquestioned. And let's be clear, I mean, this is not a criticism of this operation. I mean, this epoche of objective science is extremely powerful and fruitful. It's a very productive move, and you can actually find it in the history of science relatively often, especially during revolutionary episodes of sciences, especially at times where scientists are simply not quite sure which metaphysical or ontological register to choose. But at the same time, and this is the philosophical point in the context of this talk, the localized nature of this epoche of the natural, of the positive sciences is also the reason why Heisenberg's epoche of objective science does not change Husserl's basic point about the naivety of science. Because the naivety that remains, at the very least, concerns the meso and macroscopic objects of everyday practice. So let me summarize and briefly look where we are in the argument. So far, I have discussed two ways in which one could challenge Husserl's claim according to which the positive sciences always and necessarily must be naive regarding the points of departure. And what I tried to show is that basically both of these criticisms of Husserl miss their target. I think if you're an orthodox Husserlian, you could defend the Husserlian project against both of these criticisms. Where does this leave us? I think we need to talk about something slightly different. And I think the actual heart of the discussion we should talk about is an implicit presupposition, not only Husserl, I think many people thinking about science are making, namely that scientific theories, mathematical models, always are representational vehicles, that representation is the basic feature which is important to understand what theories and models are doing. So what does representation mean here? Well, it means that basically the mathematical structures you find in science, the mathematical structures that are encoded in the equations and the mathematical models, we're using both the theory models and the data models, stand in for something which is distinct from them. Something which is not mathematical unless you're a mathematical monist, but I think there aren't that many Max Tegmarks out there. So the mathematical structures stand in for something which is distinct from themselves, a physical target system. And we reason then about these models basically as surrogates for the parts of reality that we're interested in and that we cannot access directly. I mean, you know, in solar neutrino physics, you're talking about the PP reaction that's supposedly happening at the heart of the sun, at the core of the sun. The only way to figure something out about this is to look at the mathematical model, because A, we can't go there, and B, if we could, we should not, because it's pretty hot. What's important about this assumption of representationalism, if you look at the discussion about scientific realism in analytic philosophy, if you're familiar with that discussion, this is something which is shared all across the board. Representationalism really cuts across the entire debate. If you look at a prototypical anti-realist like Bas van Fraasen or a full-blown realist like Stathis Psillos, they both share the assumption of representationalism. So this is how deep this assumption is. And what I want to say is that the naivety Husserl talks about, I think at the end of the day, is a consequence of this representational nature of science. So in order to establish any kind of relation to something beyond them, theories must presuppose that something beyond them exists, whatever it may be, however you want to describe it. And this is the basic presupposition that cannot be addressed within science itself, and this, for this very reason, is the source of this necessary naivety of science. But what if science is not representation? Or at the very least, what if science is not always representation? I don't think that Husserl ever considered this possibility, and I think a lot of people thinking about science aren't considering this possibility either. But just to see what this would change in the context of this talk and regarding Husserl, I mean, if there were at least instances of science where this basic representational presupposition does not work out, then Husserl could no longer claim that all sciences are necessarily naive. I mean, of course, it would also change pretty much the image we have about science generally, but in the context of this talk, this is what I would mostly focus on. This, of course, raises the question, non-representational science, what could that be? I mean, could we think of an example? Well, I think there exists actually an example, and I want to briefly talk about what I have in mind. I don't know if you have heard of this, but QBism, a quantum Bayesianism, is an information theoretic interpretation of quantum mechanics, which I think is a concrete example of a non-representational theory in physics. I will very briefly say a couple of basic things about QBism. And no worry, you don't have to know a lot about quantum mechanics in order to see what the philosophical point about all of this is. But basically, what QBists are saying is that the quantum states, or the basic heart of the mathematical formalism of the theory, simply does not want to describe a segment of physical reality. This is simply not what quantum mechanics is about. Instead, it encodes an agent's degrees of belief about the outcomes of her future experiences. QBists will say things like quantum mechanics is an addition to the basic Bayesian calculus of probability, just tuned for one specific empirical domain. And just to show that I'm not making this up, here's a quote from Chris Fuchs and Rüdiger Schack, both physicists, not philosophers, by the way. So quantum states do not represent an element of physical reality, but an agent's personal probability assignments, reflecting his subjective degrees of belief about the future content of his experience. This is what quantum mechanics is about. And QBists actually, again, even though they are physicists and not philosophers, but they are actually quite explicit about what this means for the general idea of science always having to be representational. Now, here is a characteristic quote by Chris Fuchs and Blake Stacey. The very correct character of the theory seems to point to the inadequacy of the representationalist program when attempted on the particular world we live in. There are no lofty philosophical arguments. This is a very typical physicists will. No, it's not philosophy. I mean, actually, I'm talking about philosophy, but don't worry, it's not philosophy. So there are no lofty philosophy, and also philosophy equals lofty, sure. There are no, I like both of them, but this is always the same. There are no lofty philosophical arguments here that representationalism must be wrong always and in all possible worlds. I mean, they're talking about possible worlds, sure. Perhaps because of some internal inconsistency. Representationalism may well be true in this or that setting. We take no stand on the matter. We only know that for nearly 90 years, quantum theory has been actively resistant to representationalist efforts on its behalf. Okay? To complicate the discussion a little bit, I actually thought whether I should cut this part out because now it's getting a little bit more in different directions, but I think it's important to be precise with these things. Because in my discussions with Chris and Rüdiger and the QBist folks, I'm sometimes not sure how non-representationalist QBism really is. In order to explain what my worry is, let me say a few things about this. If you read philosophy of quantum mechanics, then there is usually a basic distinction people make, namely a distinction between psiontic and psi-epistemic interpretations of quantum mechanics. And what this is about is basically psiontic interpretations claim, and this is now, I hope no one's working on philosophy of quantum mechanics because this is a very crude way to talk about this, but basically, if you like psiontic interpretations, then you say that the wave function, psi, offers a description of external reality. What that actually means, there are different views on what this actually implies, but this is the basic message. If you like psi-epistemic interpretations, then what you're saying is that the wave function just describes our incomplete knowledge of that external reality. So it's really basically a distinction between whether you think that the theory comes with strong ontological metaphysical impact or if it's just about epistemic things. But note here, and this is really something about how fundamental representationalism and all these discussions is, both of these interpretations presuppose representationalism. Because either the wave function represents reality directly because it's ontological, it's about stuff out there, or, since knowledge is factive, it does so indirectly because it's knowledge of something. So you're not getting away from this representationalist basic logic. And this is also the reason why QBists and philosophers who are friendly with QBism basically say that QBism doesn't fit into this. It's neither psiontic, and it's also not psi-epistemic. Because the whole point of QBism is that the quantum state is not about knowledge, it is about beliefs. And beliefs are not factive. So it's a different category, and it seems to be more plausible to think that it's non-representationalist. Harry Spern, a physicist slash philosopher, actually claimed that we need a third label. So QBism is neither psiontic nor psi-epistemic, it's psi-doxastic. But, I mean, it's a nice label, sure. But I'm not sure if this really helps QBism to really become this strongly anti- or non-representationalist theory. And my worry, really, just in a nutshell, is this. I mean, granted, beliefs are non-factive. But, I mean, isn't it still true that beliefs are necessarily beliefs about something, especially if you assign probabilities to them? If you say one belief is more probable than another one? I mean, unless one accepts solipsism, and this is really one of the main criticisms against QBism, there seems to be still a minimal sense of some kind of assumed reality regarding to which beliefs can be more or less probable. I simply don't see how by simply saying it's beliefs, it's non-factive, you completely get out of this representationalist logic. And I'm not the only one. There are people who say, yeah, this is exactly the reason why QBists should actually join the phenomenological camp, because the idea basically is to connect the QBist understanding of the quantum state as an agent's degree of belief about future experience with what phenomenologists mean when they talk about the horizontal structure of intentionality, or their basic account of intentionality as horizontal. You probably haven't heard about what it means to talk about intentionality as a horizontal structure, so let me briefly explain what this is about. You'll see it's not rocket science, it's just phenomenology. I mean, imagine you're looking at a coffee cup, or any, I don't know what it is with phenomenologists and coffee cups. It used to be ashtrays. That's a little bit out of fashion, maybe not in Europe. I mean, we're more at liberty to still talk about ashtrays, but still, it's mostly coffee cups. Sometimes it's blooming apple trees. We should really come up with better stuff. So you perceive a coffee cup. In this situation, it's just, we're not in the philosophy seminar room. It's a simple situation of just you looking at an object like a coffee cup. The perceptual content, so basically what you mean in perception, is a three-dimensional object in space. This is basically what you are interacting with. But then, and this is how also many seminars in phenomenology start, take a step back, ask yourself, is this really the case? Then what people are realizing is, well, what's actually sensuously given to me in this situation is not the full-blown thing. I mean, honestly, all that's given to me at one concrete time or point in a perceptual episode is really just the one side that is facing you. It's only always one perspective of the thing. But still, what you mean in perception, it's a three-dimensional thing, not just something that needs to be constructed out of two-dimensional perspectives. So phenomenologists make a huge deal about this, but basically what they want to say is that in perception, there is always necessarily a gap between what's meant, so the full-blown three-dimensional object, and what it's sensibly given, so, a series of partial perspectives. And this gap is structural. It's not contingent. It's also not something, I should say, even though I will not go into this in detail, it's also not something that's only true of perceptual experience. It's also something, if you think about how you hear chord progressions, for instance, you find the structure there too. So experience has a horizontal structure. There is a center of actuality, the side that's currently facing you, and this is surrounded by this host or horizon of anticipations of future possible appearances. And these anticipations can be more or less wrong. That's the basic structure of experience. So basically what you can then say is that, well, to experience a coffee cup in its full concreteness, in its perceptual depth, is already to anticipate its hidden sides, its backside, underside, further profiles, and so on and so on. So experience really for the phenomenologist is this probing of the horizon, for instance, by walking around it, or picking the thing up, turning it around, breaking it open, whatever. And based on this, a French philosopher of physics, Laura de la Tremblay, has suggested that this is actually exactly what QBism needs. On her interpretation, quantum mechanics, if you read it through the lens of the QBists, can be understood as a mathematical articulation of exactly this horizontal structure of intentionality. So here is Laura. The QBist will modify her state vector according to the results obtained in order to optimize his subsequent bets. The same is found in Husserlian phenomenology. Several futures were open to me at the time of the fall of my coffee cup. Again, it's coffee cups. After the cup burst into pieces, the anticipation of the cup remaining undamaged is frustrated, and other anticipations come to the fore. The cup is the analog of the macrosystem. The perceptual horizon parallels the QBist quantum state. The perceptual act corresponds to the physicist's measurement, and the modification of my possible horizon corresponds to the modification of the state vector after the measurement. So if Laura is right with this, and she's not the only one, by the way, quantum mechanics is a genuinely non-representational theory. The mathematical formalism, if you go through with this interpretation, is simply not about describing a hidden physical system. It is about something else. What it articulates are the structural constraints governing our expectations about experience. And this raises an interesting possibility. Quantum theory may reflect structural features of how reality is encountered by agents, not reality per se. Let me come to my conclusion. So we started by saying that Husserl argues that the positive sciences are necessarily naive. But I think that this view presupposes a very specific picture of science, namely a representational idea about what theories and models are at the end of the day. And I would say that quantum mechanics and QBism is just one example. There are other interpretations that go in a similar direction. The London and Barr interpretation is one of them. Quantum mechanics raises the possibility that this basic picture is wrong, at least in one area of physics. So interpretations like quantum mechanics or the London and Barr interpretation suggest that there is a different possibility. Quantum theory may not represent a hidden physical system. It formalizes how agents structure their expectations about experience, very much in the way how phenomenologists talk about experience since Husserl. And again, QBism is really only one example. And also, the point of my talk is not to be wedded to this specific interpretation. I'm not quite sure if I buy the QBist story. Again, there are different interpretations where you could make a very similar argument. What's important for my talk is really just that non-representational science, non-representational theories, I think, are not a priori possible. And quantum mechanics might be a very good candidate for this actually being the case. The small outcome for the Husserl nerds is that Husserl's diagnosis must be revised. Well, yeah, sure. Quantum mechanics indeed would not be any longer a naïve science describing hidden objects. Instead, it would articulate the conditions under which reality becomes experienceable for agents. And this is now the punchline, the mic drop moment. What this means is that quantum mechanics actually really begins to look like something Husserl never in his wildest dreams, and I think some of his dreams were pretty wild, anticipated a kind of transcendental science. Thank you.
So we usually the first few questions for the students.
Yeah, I kind of like a two-part question. And so the first part is, how can we use phenomenology of science and make it more like empirically grounded and use it in other, I guess, fields? The example I'm thinking of is Christopher Tilley and like the work he did with archaeology and the phenomenology of landscapes. There's obviously a lot of drawback to that, criticisms. So I guess, yeah, the two questions combined are, how can we use this, maybe like interviews or something, like with other fields, not just quantum mechanics and physics?
Mm-hmm. That's a great question. I mean, I don't know too much about the discussions in phenomenology and archaeology. I mean, I know that there are very interesting connections. A colleague of mine in the Netherlands is working on that. You might be familiar with his work, Corin van Maaseik. He managed to actually get phenomenology in all the important handbooks for archaeological research. It's really amazing work he's doing. But I don't feel competent to talk about this specific area. But I think that the question is a more general one, and it's also one that really affects my own work quite a lot. Because when working with physics, I mean, let me take one step back. If you're a phenomenologist, then I think one of the things you really find very important is a descriptive approach. So you don't want to immediately go into the kind of puzzle solving a lot of philosophy is dealing with. What you first want to do is to have a lot of patience to describe the phenomena you're dealing with. Okay? Like for instance with perception, phenomenologists will spend an unreasonable amount of time to analyze very mundane examples like looking at an object, and then you have pages and pages and pages of description of what's happening. This is a very distinctive feature of phenomenology. But now you are a phenomenologist of science. What are you actually describing? and this really became a huge problem for me at some point in my work when I was writing a paper on a phenomenological interpretation of how we are using mathematical models, in my case in physics. And all of a sudden it kind of occurred to me, all I'm describing is actually my experience of dealing with mathematical models. But who am I? I mean, maybe many things, but I'm not a practicing physicist. And I think there is something about the expert experience of someone who works in a lab each day, every day, which is almost impossible to replicate from the philosophical armchair, even if you have a physics degree. Even if, I mean, if you talk to physicists, like, it seems what they're telling you is that there are at least 3 different layers of what the experience of doing physics consists of. There's on the one hand, the mathematical formalism. It's basically what you find in the textbook. You read the textbook, there is math, you need to understand certain mathematical tools in order to understand what mathematically is going on. Okay, that's one level. The second level is a conceptual level. Physicists, of course, also use natural language to talk about what they're doing, especially in the laboratory context. I mean, you need to tell your colleague what you're about to do, but how should you say this in mathematics? So you talk about things, and the conceptual level and the mathematical level stand in very interesting relationships to each other. Because, for instance, on the natural language level, all of a sudden people, even in quantum mechanics, talk about entities, particles. Well, but there are very good reasons to think that there are no entities, there are no particles, but still you need natural language to talk about stuff somehow. And then there is a third level, which is really the level of the kind of skill you need to have in order to run an experiment. And with experimentalists, it's very interesting. I mean, a lot of what they're doing is tinkering. Like, I spend a lot of time with the quantum information people, the people who are working in the quantum information lab at my institution. And for instance, a very typical situation would be, Lasse, the beam splitter is not working as it's supposed to be. Well, ask Ulf, he knows this thing. And then Ulf comes and does this thing. And you ask, Ulf, what did you just do? Yeah, I don't know, it's just like you need to shake it like that. My point being, if on the one hand, as a phenomenologist, you think that description is the way to go, but if on the other hand, I don't have access to this very specific experience a practicing physicist has, simply because it comes with a lot of tacit knowledge, it comes with a lot of things that do not end up in textbooks, what am I even describing? And this is a real problem for me. I just wrote a paper on that topic that ended with, I don't know the answer. And it kind of worries me. One option is in some areas of phenomenology, because phenomenology of science is not the only area, similar problems, for instance, can be found in phenomenology of, for instance, psychiatry. If you're dealing, for instance, with cases of ways to perceive reality that are arguably quite different from the ones we normal people experience, how should you deal with this? There's a whole tradition in this area that is utilizing qualitative interviews as a kind of a substitute or extension of the philological method. So you're basically doing a special kind of interview and then using the interview as a kind of material to do descriptions on. I can see the attraction, I also see certain problems with that, but going back to your first question, how can phenomenology go closer to a kind of an empirical grounding? I think it's especially methodological questions like that where I think we can learn a lot from our friends in sociology, in ethnographic fieldwork, these kinds of areas. I think this is what's exciting about phenomenology of science. There are many dissertations that need to be written, like for instance on this particular question, and I don't have a ready-made answer. This is something I work through myself. Questions?
So within the context of the phenomenology of science, you focus on Husserl, very reasonably of course. But I'm wondering, just as like a novice philosophy, do Heidegger or Sartre present any interesting or fruitful contrast to this discussion, or at all, or to Husserl?
I mean, this might be a really weird thing for me to say, but I couldn't care less about Husserl. And it's weird probably after this talk, but Husserl really for me is a kind of a springboard. This is always how I looked at this. I mean, Husserl wrote an unreasonable amount of pages, 40,000. And there is lots of good stuff to be found, but also lots of stuff that I don't find so impressive. And I personally, I'm really not interested in getting the historical Husserl right. If I find something in Merleau-Ponty, for instance, who actually did quite interesting stuff on physics very late in his career. There is a series of lectures he gave at the École Normale Supérieure, where one lecture series was specifically on quantum mechanics, and it actually blew my mind because I was reading it and I thought, like, I had a different image of Merleau-Ponty. I did not think that he actually understood so much physics, which, if you read it, he obviously did. There's a historical story why that is the case, but in general, absolutely. I don't think of myself as a historian of phenomenology, even though I'm interested also in the historical trajectory. But I mean, I have a very open-minded sandbox attitude, and also it's not about phenomenology. I mean, maybe phenomenology of science is the kind of label I roll with because it's a nice niche. But I mean, there are things where I would simply use much more conventional methods, which you would find in analytic philosophy of science and physics as well. So when it comes to this question, a methodological pluralist, show me something that's interesting, and if I also find it interesting, I will integrate it into my toolbox. So this is, even though it was a little bit focused on Husserl here, because I needed some kind of hook to kind of connect it to, but I think the basic, especially this argument about the naivety of the sciences, this is really something you find in a lot of philological literature. I think historically it goes back to Husserl, but there are different versions of this which you find in Heidegger, and you find it in lots of generations of phenomenologists afterwards. But it was not, even though I might not have given the impression to talk on Husserl per se. Thank you.
We can open up. Oh, yeah.
Yeah, thank you. This was super interesting. I have almost no background in phenomenology, but I am a philosopher of science, and I'm very influenced by the pragmatist tradition. So thinking about Peirce, the fixation of belief. Okay, so I'm making this representationalist assumption, but it hasn't caused any problems for me. Okay, maybe in quantum mechanics, but in other domains, it hasn't been implicated in any problematic situations. So what's wrong with me just, continuing on with that assumption? Another way to think about the question would be sort of what's the aporia behind representationalism?
This could be the shortest answer to a question I ever gave. What's wrong with representationalism? Nothing. Like, I'm not denying that, for instance, if you look at models in fluid mechanics, they are representational. They are simply meant to represent fluids going through pipes. That's what they do. And there is absolutely nothing wrong with that. I think there are two things. In the specific context of this talk, I think what I was attacking was the, I think, unreasonably strong claim Husserl is making about all positive sciences, whatever positive science is, needs to be representational. I mean, Husserl is not saying it this explicitly, this is my interpretation, but I think at the core of his claim, which is a sweeping one, about any theory that can ever be a positive scientific theory, that it needs to be representational. This is what I wanted to attack, and in that case, one example would be enough to show that the generalization is not going through. I completely agree with you that representationalism, like many of the metaphysical assumptions we've been making in science, even though from a philosophical point of view you might be critical to look at them as a generalized image of how we should think about the basic structure of reality, were hugely successful if just used in a particular domain. I mean, think about many of the presuppositions you find in classical Newtonian mechanics. To assume that you can get information about a system without disturbing the system, I think arguably does not make any sense. It wasn't true in classical mechanics, and it's definitely not true in quantum mechanics, but it was hugely successful to use this, to simply assume that it's possible. I mean, this is, I think, at the end of the day, really what Husserl is talking about, and what I find is interesting in Husserl. I think this is really the core feature of idealization, and using idealizations to actually figure something out about empirical target systems. That on the one hand, this is hugely successful, but there is also a certain danger in it, that if you're not reflecting philosophically on what you're doing when you're applying idealizations to physical target systems, you're always running the risk of basically telling a, I think, unreasonable metaphysical story about it, or around the idealizations. But I completely agree with you. This is not meant to be a sweeping claim about science never being representational. I wouldn't even know how to think about it. In that sense, I think, yeah, this is a claim about quantum mechanics. This is the only example I know where I would think that the claim that physics becomes non-representational has some plausibility, but I would not extend it beyond that. I think in that sense, I do believe that quantum mechanics is far more radical than at least the scientific theories I'm aware of. Because I do think that in quantum mechanics, you're not only getting a physical theory in the sense of describing something, you get a whole epistemology. But some people think that's not the case, that's okay as well, but I would not extend the claim beyond quantum mechanics.
Yeah, I'm trying to formulate exactly what my question is, but I guess this idea that you have that QBism seems like it is representational in some way, it feels right to me. And one place I see that is in the time assumption. So in the definition that you had of the view, they say that their subjective beliefs will change over time. And I think that minimally assumes that there's times separate from their current beliefs, which is something separate from themselves, presumably. Mm-hmm. And then just like what Bayesianism is, you're updating your beliefs because you're assuming you're getting closer to something that's outside of yourself. Bayesianism doesn't make any sense unless you're assuming that, I think. Mm-hmm. So I do think that that's there. But I feel like if QBism isn't there yet, I feel like a scientist could push back in a stronger way. And I'm looking at my phone because I wanted to get close to your slide. So you said that the problem is that science presupposes a pre-given nature. But I think the scientists could say that instead, some future scientists, all that they presuppose is that there's an activity that they can do together that will arrive at better knowledge than an activity that they could do alone. And there, I feel like the scientist would challenge the phenomenologist in an interesting way. It seems like the phenomenologists presuppose that they can arrive at better knowledge alone or through reflection. So in your description of some of these cases, you said like the coffee cup doesn't, what you really see is just the 2D, sorry, 2D image. But that claim about what is actual or what is real seems like it presupposes that what you can arrive at alone is more significant than what you can arrive at together. And along the lines of what Dan was saying, I'm just curious about that, like whether you could justify that. Because to me, that's not the way I'm built. I kind of feel like I think that what we can arrive at together seems most of the time more substantial. It doesn't have the delusions and the conspiracy theories that people working alone have. So do you think there's any promise in this path for the scientists?
No, thank you. Thank you to both of you. Really good questions. So there are two things here. There's the QBism issue, and then there is the issue about intersubjectivity. Let me take the QBism thing first. I completely agree. I mean, QBism historically really took the most radical subjectivist interpretation of Bayesianism. The whole definitely like, there are no probabilities. There is nothing objective to this. I mean, what QBists believe is that basically coherence alone is saving the day. It's all about Dutch book arguments, and it's basically just by you place your priors wherever you want, and then it's just about maintaining coherence, and there is only one rule, that you don't end up with a Dutch book scenario where you're guaranteed to lose. That is the only normative criterion. And then comes the interesting bit. They are trying to connect the whole Dutch book discussion in Bayesianism with the Born rule in quantum mechanics, and try to connect those two, and basically say that the Born rule is the equivalent of like the maxim to prevent Dutch book scenarios in the quantum realm. And this is where the normative traction comes from. But they really believe that wherever you place your priors, doesn't matter, it's just about coherence. But to me, it doesn't really add up, because I mean, to assign probabilities to beliefs seems to imply something about something the belief is about. I wouldn't even know how to talk about beliefs if there was not something the belief refers to. And this is really where I kind of feel like, and you know, with the QBists, it's also historically, it's part of this whole, first of all, quantum information paradigm, and then also quantum reconstruction paradigm, where the idea basically is quantum mechanics is so confusing because what did not happen so far with quantum mechanics, what happened with relativity theory, is that we could actually reduce the whole formalism to plausible, intuitive, basic principles. Like if you look at special relativity, this is the philosopher's dream. You have two principles, you have one definition, everything flows like Euclidean geometry, and everything's crystal clear, and you get simultaneous, relative, and all these things, and it's very nice to teach, and you have thought experiments and all of that. Quantum mechanics is not like this. It's a mess, it's a hot mess. And these reconstruction people think that, yeah, the reason for that is simply we didn't do our homework. We didn't do what Einstein did for special relativity, so we need to kind of find what the ultimate principle is, and for the QBists it's the Born rule. This is basically the thing. But I agree with you. I don't think it makes sense, and this is where I think this whole exchange between phenomenology and QBism becomes interesting, because I think if you talk to QBists, you basically get the image that they're presupposing way more than they're willing to admit. They presuppose, first of all, an agent. Here, like, by definition, an agent is something that acts on something. What is the something here? Like, where does this come from? So there is a lot of stuff presupposed. And I feel like phenomenology could potentially be a way to kind of fill these gaps, because the thing I was talking about, this horizontal structure, I think what's important, and this leads me over to your second question about intersubjectivity. When phenomenologists talk about, for instance, perceptual horizons, they talk about coffee cups, and they talk about how, you know, one side is only given to you, and then co-given are anticipations, then people sometimes feel like, yeah, I mean, that sounds about right, but how is that not psychology? How is that not just a description of, yeah, what just happens in perception? Some phenomenologists like me would say, look, horizons do show up on the level of empirical subjects that can be studied by empirical psychology. But they also show up as a transcendental condition of the possibility of having any kind of experience at all. What we're talking about when we're talking about horizons is a fundamental transcendental structure that is already in place in order for any kind of reality to manifest itself. This is a strong claim. Many people think that transcendental analysis in itself doesn't make a whole lot of sense. That's okay, we can discuss this. But I think the kind of interpretation I was relying on very much was a transcendental one. Like, horizons are interesting for psychologists, and they're studying these things. If you look, for instance, in cognitive science, how people talk about I don't know, object constancy, color constancy, all these kinds of phenomena. I think this fits very well into the story phenomenologists are telling, but I'm more interested in horizon as a transcendental notion. And this is also exactly the kind of direction I think QBism could go, to kind of appreciate that. But I know it's a bold claim, because basically it makes quantum mechanics the first transcendental piece of science, and this is, of course, a lot to ask for. Regarding your intersubjectivity point, I can totally see where you're coming from, and it kind of connects to the first question we had about description. So when people hear about phenomenology, then the impression people sometimes are getting is that, okay, so you're doing introspection. So you're describing your own consciousness, because arguably that's all you have. I mean, I have no access to your consciousness. All I can do is study mine and hope that what shows up here is also true in your case. I mean, this is a long discussion, and it's a long discussion also in Husserlian phenomenology, because I think for Husserl in the beginning, he very much gave the impression that it's a pretty radically subjectivist methodology, and it really is a form of like looking at your own mental states, then describing those, and then the question is, how can you generalize that? But I think increasingly, when Husserl refined phenomenology as a transcendental project, I think he more and more realized that we need to be very cautious with terms we use on the level of the natural attitude and notions we use on the transcendental level. Like, to describe consciousness transcendentally right from the get-go does not mean to describe my consciousness or your consciousness. I think these strict separations between yours and mine is already something that's constituted on the level of the natural attitude, and does not necessarily make sense on the level of a transcendental description. I mean, one way I like to think about these things is how you use transformation rules in physics. If you stipulate a coordinate system to describe a physical occurrence, then stipulating the coordinate system is necessary, because otherwise you would not know where your physical occurrence is happening. But just stipulating one coordinate frame is not enough, because you could not tell apart what's objective about your description or what's just an artifact of placing the coordinate frame here instead of there. So you need transformation rules. You need mathematical rules that tell you how you can boost the coordinate system in different directions, how you can rotate it, and so on and so on. And objectivity then only comes if you using the transformation rules to move the coordinate frame around, and you can look at what stays invariant and what changes. The stuff that changes, you just throw out of the window, because that's an artifact of you placing the coordinate system here and not there. But what remains invariant, that's the objective stuff. In a way, the way I think about intersubjectivity on the level of transcendental analysis is very similar to that. If you ask yourself, oh, the phenomenologist tells me there is a front side, but then there is an anticipation towards co-given backsides. What is the status of these backsides? Who is constituting them? I would give a very similar answer to the description of what transformation rules do with coordinate frames. That is part of the objectivity claim that's there. It's you presupposing right from the get-go how the thing would appear from potentially all different perspectives. This is, of course, highly fallible. I mean, if I enter a room where I don't know the objects, many of my anticipations will turn out wrong. I assume that the object has the same color on the backside. I haven't never interacted with the object. Turns out it's completely different. But I think the claim of objectivity that's in perception very much presupposes something quite similar to transformation rules in physics. But this is a long discussion, and I completely see why you're having the kinds of worry you're having.
Yeah, unfortunately, David, I don't think we have time.
I'm good, that's fine.
So let's thank our speaker one more time.